let's talk about how we can find the centroid of a region by using integral. But before we do this, let's talk about a non-calculus case first. The center of this shape, it's not rectangle, right? It's like this here. We have a missing corner here. But it's okay, because if you look at just this, the center of a rectangle is just right in the middle, halfway from here to here and halfway from here to here. And the center is where you can place your finger and can balance this rectangular plate. So this is how we are going to do it. First, we are going to just break this into two rectangles. And then, in order for us to tell the location of the centroid, we will need a reference frame. I'm going to set up my x-axis down here, and I'm going to set up my y-axis right here. I think it's a pretty natural choice of doing the x and y. Now, first, we have to find the location of the centroid of the first rectangle and also the second rectangle. For the first one, half of 2 is 1 and half of 6 is 3. So let's say somewhere here, we have 1, 3. For the next one, half of 4 is 2, but we have to come from here. So 2 plus 2 is 4. And then because from here to here is equal to 6, and then 2 more, so the whole thing is 8. Half of it is 4. So let's say it will be somewhere right here. It will be 4, 4. And now, for the whole thing, it looks like somewhere here. A little bit to the right of 3, because we have a missing part on the left. And a little bit down below 4, because we have a missing part on the top. So I will just call this x bar, y bar. That's the centroid of the whole thing, like this here. So how do we do it? Here is the deal. For x bar, what we want to do first is we are going to look at the central, the x coordinate of the centroid of the first and also the second, and then we have to multiply by its corresponding area of the region. So I'm going to call this shape right here A1, and I'm going to call this shape right here A2. So as a formula, we will have to first compute the sum, and let's say I goes from 1 to 2, because we just have 2 parts. If we have 5 rectangles, then I will just put down I goes from 1 to 5. And then we will have to do xi bar. This represents the x coordinate of the first centroid. And when I is equal to 2, that will be the second one. And we will have to multiply by the corresponding area. So we just put that down as ai. And then divided by the sum of all the areas. So the sum I goes from 1 to 2 of ai. And now you might be wondering, why is the formula like this? Let me give you a one-dimensional case first. Let's say we have a 10-meter weightless bar, and I'm going to put a person here with mass m1, and then I'm going to put another person here with mass m2. In another word, this is called the point mass geometry. Again, this is weightless, so it's not going to contribute anything to the total system. Well, imagine we are playing seesaw. How can we keep this balanced? Assuming m2 is bigger than m1, then we should put the centroid toward m2, right? So it's going to be somewhere like this, maybe? Yeah? And to do the precise computation, we also need to worry about the distance from here to here. Let's call that d1, and then let's call this distance d2. I will tell you this system will be balanced if d1 times m1 equals d2 times m2. So what exactly is d1 times m1 do though? This right here is called the moment. It's just like, imagine if you want to feel the moment, just hold up something heavy like the 2 markers here. Distance times the mass, you can feel the moment. The moment that we are doing moments in calculus. So this is the tendency of turning this way, and this right here, the moment, is the tendency of turning this way. If they are equal, this right here will be balanced. And let's actually figure this out with actual numbers, why not? Let's say M1 is equal to 60 kilogram and M2 equals 140 kilogram. I'm going to figure out D1. So I'm just going to say D1 times M1, which is 60. I should make that equal to D2, but we know the whole thing right here is 10. Subtract D1 will give us D2, so I will just put it as 10 minus D1, and then times M2, which is 140. I'm going to distribute the 140. I will keep this as 60 D1, and I'm going to keep this as 10 times 140, and then minus 140 D1. I'm going to bring this to other side, but I'm going to write it as 60 D1 plus 140 D1, and we'll make it equal to this right here is 10 times 140. I'm going to factor out the D1, so I have 60 plus 140, and then D1 equals whatever that is. But again, I'm just going to write it down as how it is. Then I'm going to divide this to here, so you will see that D1 equals whatever this is, right? We have 10 times 140, but we will have to divide it by that, which is 60 plus 140. In fact, if you take a look at this expression, it's quite similar to what we are about to do. We have the distance times the area here. This is the distance times the mass here. Why are we doing just the area? Here is the deal. If we are talking about the centroid of a region, we really just have to care about the area. This is why. Because imagine we have a rectangular plate. Let's just look at rectangle. We care about two things. One, how big this rectangular plate is. Two, what is this made of? How big this is the concept of area, and what is this made of is the concept of density. This is just a cardboard, so it's pretty light. But imagine this is made of gold. I will be rich, but unfortunately it's not. But if this is gold, it will be heavier, right? So we have the density. Here, we also have to assume that the density, the mass right here, is equally distributed. So it's not too heavy here compared to that. It's equal throughout. So here's the idea. We really have area times the mass density and area times the mass density. But the mass density is just a constant. Cancel the mass density. We really just have to care about the area. But anyway though, okay, on the bottom you see we have 60 plus 140, which is kind of like the sum of the area. Because remember, it's technically area times the mass density, the sum of the mass. So it's the same as that. But how about the missing part right here? Here's the deal. Remember earlier we talked about we had to set our reference frame. We have to do the same thing here too. If I put down the x-axis here, and I'm going to say here is where the 0 is. Then in that case, in the front here, technically is 0. The distance will be 0 times whatever the mass is, which is 60. And then I will have to add it with this distance, which is from here to here, and that's 10, times this mass, which is 140. If you compute it, you will see that it's just going to give us 7. So we are 7 away from the first mass, then that's D1. So that's the idea. Now, once I write it down, you will see that they are pretty much the same idea, same thing, the same expression. So for x bar, we are going to look for x1 bar, which is the one right here, and then multiply by the corresponding area. x1 bar is 1, that distance, which is the x coordinate of the centroid of the first rectangle, times the first area, just 2 times 6, which is 12. And we add the second one right here, which is the 4, times the second area. Here's 4, here's 8. 4 times 8 is 32. So multiply by 32, and then divided by the sum of the areas, which is 12 and 32. Huh? Doesn't it look like the same thing? Okay. And now if you work this out, you will get 35 over 11, which is about 3.18, which is a little bit more than 3, right? A little bit more than halfway of the whole thing. Again, because we have something missing on the left-hand side here. Now, for y bar, you can imagine it's pretty much the same thing. We have the sum, I goes from 1 to 2. Here we will just have yi bar times ai, and then divided by the sum of the areas. y1 bar, it will be this 3 here, and we multiply by the area, and then we add y2 bar, which is this 4 here, and then multiply by 32, and over 12 plus 32. And if you work this out, we will get 41 over 11, which is a little bit less than 4. So that's why I put it down right there. This is about 3.72. Now, the moment of truth. How do we deal with this when we have a curve? Of course, whenever we see curves, it's calculus time. But to deal with that, we use rectangles. First, we are going to draw a rectangle like so. And let's get the area expression. Here is just a small change in the x. Label that as dx. Here is the vertical distance. Label that with y. Now, I'm going to put x bar for the x coordinate of the centroid of the whole thing. But before we can do so, we will have to look for the centroid of the blue rectangle. Let's say it's somewhere there. Cool. Now, let's just focus on this expression. xi bar times ai, right? For the right here, we have to look at the x coordinate of this centroid. Well, in this case, we will just go from here all the way to here. The horizontal distance, and that's x. So we start with x. And then the area of this blue rectangle is just y times dx. So let's put that down, y times dx. And then the summation earlier, right now it will be the integration. Yes, integration, and because we are in the x world, we go from a to b. Aha. Over the sum of all the areas. In this case, it will be the area of the region, and of course, it's just the integral a to b of our y times dx expression. Now, here is how we take care of the look of the formula. Instead of writing this down, it's another integral on the bottom. We are just going to call a to be the integral a to b of y dx, but y is not allowed in the x world. Don't worry, it's just our function, and then dx. And we will first write it as 1 over a, 1 divided by the area, and then multiply by this, the integral a to b. Here we have x, y is the same as f of x, and then dx, y bar formula. Now, let's talk about, x bar formula. Now, y bar. Here, let's talk about the yi bar. Here, we will have to talk about how do we write this from here to here. Well, from here to here is y, but we are just going to go halfway. So here we have half y, and that's the only difference that we have to put right here. So for y bar, we have the integral a to b, we have half y, and then again the area part, like so. And then for the bottom, it's the same thing, integral a to b, and then we have y dx. And we get 1 over a times the integral going from a to b. And we like to have the 1/2 inside of the integral. That way we can have 1 over a for both of these two expressions. And then y times y is y squared, but y is not allowed in the x world. Write that as f of x. and then make sure you square that. At the end, dx. And ladies and gentlemen, there we have it, x bar, y bar.